In this video, we'll solve formulas that involve rational expressions. When solving formulas for a given variable, keep in mind the following rules. We will always use opposite operations to clear unwanted factors or addends. Let's see the first example. We need to solve this formula for C. Let's observe what operations were applied to C to build this right-hand side formula. Well, C was divided by D, and then we added 1. So now to undo the operations, we need to get rid of the last operation, which is this addition, and then undo this division. The opposite operation to addition is subtraction, so we're going to subtract 1 from both sides of this equation. Therefore, let's copy A over B as it was, and we subtract 1. On the other side, we keep the C over D as it was. And in the next step, we need to undo this division by D, so we're going to multiply the whole equation by D. To make it a bit easier, I would suggest to perform this subtraction and write the left-hand side as a single fraction with denominator B. So the first numerator is the same A, and then it's minus, instead of 1, we have B, because B over B is the same as 1, isn't it? Okay, so this is the left-hand side as it was, but now we're going to multiply by D. Where this D goes? Well, it goes into numerator, so we need to place a bracket around A minus B because this whole thing needs to be multiplied by D. And let's extend this division bar, equals our C. So we already solved for C. Let's see the next question. A equals x plus y times b over 2. We're solving for this x. So again, we want to undo operations. What kind of operations x was subjected to? Well, first we added y, then we multiplied by b, and then we divided by 2. So to undo those operations, we need to undo this division and this multiplication. This can be done simultaneously because, as you know, there is no priority between division and multiplication. So we can at once multiply the whole equation by 2 and at the same time divide by b. Or you can think of multiplying by reciprocal of b over 2, which is 2 over b. Okay, let's see how it goes. A stays as it was, that's a numerator. Since we multiply by 2 and divide by b, the 2 goes to the numerator, we can write it in front of A, and the b goes into denominator. On the other side, multiplying by reciprocal of b over 2 really cancels this b over 2, so we don't have it anymore. Therefore, what's left is just x plus y. Notice that this formal multiplication by the reciprocal of b over 2 works really like teeter-totter. What does it mean? Well, if we want to get rid of something from the numerator, it travels to the other side to the denominator. And if we want to get rid of something from the denominator, it travels to the other side as a numerator. So that's what I mean by teeter-totter. Top to the bottom, bottom to the top. That always works when we need to undo multiplication or division. Okay, so now to get x by itself, we just need to subtract y to the other side. So we have 2a over b minus y. And that's already a correct answer. However, we may want to rewrite this formula starting from x on the left side and equal it to an expression with one division bar. So let's bring this to the common division bar. B, what's in the numerator? We have 2a, and then minus, instead of y, what do we have? Y times b. So we can write by. Okay, this is okay, and that's okay as well. Both formulas are fine. The next rule to follow is we want to keep the variable that we are solving for in the numerator. How can we achieve this? If we have our variable in the denominator, we could, for example, multiply both sides of the equation by lowest common denominator. Or if we deal with a proportion, we can just take reciprocals on both sides of the equation. So let's see the first example. We want to solve this formula for C, where C is in the denominator. This time I will bring the equation to a proportion form and then take reciprocals of both sides. So let's add these two fractions to create a single fraction on this side. So the common denominator will be AB, and what's in the numerator? Since we extended this denominator by multiplying by b, the numerator has to be multiplied by b as well. So we have b, and then plus this fraction will gain a in the numerator. So we have b plus a equals 1 over our c. So now we deal with a proportion, a single fraction on each side. Therefore, what we can do is think about reciprocals of both sides of this equation. If the equation is true, then the equation of reciprocals will be true. That means I'm flipping this fraction, ab over, and let's write in order a plus b. And then I flip this fraction, but 1 over c is the same as just c. So as you see, this method works really nicely. We can quickly solve for c with not much effort. In the second example, I'm going to use the multiplying by LCD method, so you can compare the two methods and choose the one that suits you better. So in this case, if we want to get rid of a, b, and c, let's multiply by these three letters. Therefore, if we multiply the first fraction 1 over a by abc, the a will be reduced, so we end up with just bc. Then 1 over b times abc, the b will be reduced, so we end up with AC, and equals 1 over c, this time c will be reduced, so we'll end up with AB. Great! Now our variable b is already in numerator. There's no denominators anymore. That's good. However, it is in two places. So what we need to do is put together these two terms on one side and bring the AC to the other side. So we have BC minus AB equals negative AC. Finally, let's bring b to one place by factoring it. So let's pull the b out of the bracket, and in the bracket we have c minus a equals negative AC. To leave the b by itself, we need to undo this multiplication, so let's divide the whole equation by c minus a. Okay, we end up with b equals negative AC over c minus a, which is already good. Or we can rewrite this fraction equivalently by annihilating this minus, putting this minus into the denominator. So b could be written as AC over, and then switch signs in the denominator, so a minus c. Here we go. As you see, these two examples were very similar, and the reciprocal method works a lot faster. However, some of you may feel more comfortable using LCD method, and that's okay too. A piece of advice for the reciprocal method: make sure that you have a single fraction on each side. Don't take reciprocal of each term, because obviously this equation is not equivalent to a plus b equals c. Okay, so we can't really take reciprocal of each term as it goes. We can only take reciprocal of a single fraction on each side of the equation. That's why I added these two fractions first. Okay, this wouldn't be true. And the last rule that we want to talk about: bring your variables to one place. We actually already had a chance to use this principle on the previous slide, but let's see two more examples that are a little bit more difficult, because this time the variable appears at two different levels, not only denominator, but in the numerator as well. So what we need to do first is to make sure that we have no variables in denominator, clear denominator. That means let's multiply the whole equation by 1 plus AT. So we have p times the bracket 1 plus AT equals, and since we multiplied by this denominator, the denominator is gone, so we really have just AT. Great, so now we see t at the same level. That's already good, but we need to bring those t's to one and the same side. How to do that? Well, we need to unpack this bracket to reach the t from inside the bracket, right? So let's multiply by p first. That will give us p plus APT equals AT. Okay, so what's the next step? Yes, we need to bring both of these terms that involve t to one and the same side. For example, to the left. In the meantime, we're going to bring this p to the right. So let's start with apt minus this at equals negative p. Remember, every time we move the term to the other side, we change the sign, right? And finally, to make sure that t is in one spot, factor it. So we factor t out of the bracket, and in the bracket we have ap minus a equals negative p. The last step, let's undo this multiplication, so we divide by the whole bracket ap minus a. Therefore, the final answer, t equals negative p over ap minus a. And the last example, again we need to solve this formula for n, and we see that n appears in two different levels. So we need to get rid of denominator first, bring it to the same level, to the numerator. So let's multiply the whole thing by nr plus e, and we'll get I times the whole bracket nr plus e equals n times e. Okay, what next? Well, the same as before. So it's a good idea to stop the video and try to finish this on your own. Okay, we multiply by I, release the bracket, so we have IRN plus IE equals NE. As before, we want to keep those terms that involve our variable n on one side. What for? Well, to factor it in the next step. So let's do it. IRN minus NE equals, and if we bring this IE term to the right, it becomes negative IE. Okay, one more step. Let's factor n out of the bracket. What's inside is IR minus E equals negative IE. And then to get n by itself, we need to divide by the whole bracket, IR minus E. So n equals negative IE over IR minus E, or if we don't want to see this negative in the numerator, we can bring it to the denominator, and that becomes IE over E minus IR. And that's done.